Hi, we're students from Ambrose University in a Nanoscience and Technology class. Today we are excited to show you a cool demo that demonstrates the difference between nanoparticles and regular particles. In this demo, we will be using silver and seeing what pure silver particles look like normally, and what they look like when we turn pure silver into nanoparticles. First, let us explain what a nanoparticle is. Nanomaterials are simply particles that have at least one dimension in a nanosize, which is 10 to the power of -9 meters. Materials have very different properties when they become nanoparticles, which can be very useful for a variety of applications.
In the reaction for making the silver mirror, the silver ions that have a +1 charge react with ammonia, and glucose is used as a reducing agent. This allows the silver to gain an electron within a basic medium to become neutral. These regular silver particles are then able to coat the sides of the container and form a silver mirror. But in the reaction for silver nanoparticles, the silver ion is first reduced with a reducing agent to form individual neutral silver nuclei. But then citrate is also added, which prevents a lot of aggregation of the silver atoms to occur, to allow the small aggregated particles to be nanosized. As you can see here, citrate forms a stabilized silver nanoparticle by forming a circle around the silver particles and preventing further aggregation. These nanoparticles have different properties, like we've said. Silver nanoparticles have a dull yellowish brown color.
In the silver mirror procedure, one of the chemicals being used is ammonia, and it has the WHIMS properties of being corrosive. It is also damaging to the ozone layer and damaging to aquatic environments. For these reasons, we're going to be doing the procedure under the fume hood.
In our silver nanoparticle procedure, we're using a chemical called silver nitrate, and the only WHIMS property it contains is being corrosive. So this means we don't need to use it in the fume hood, and we want to remember doing all these procedures that we're wearing proper lab equipment. So we have our safety goggles on, our gloves on, we have our lab coat on, tied up, our hair is tied back, and closed-toed shoes.
First, the solutions are made. A 0.2 molar 100 milliliter solution of glucose is made. A 0.8 molar 100 milliliter solution of potassium hydroxide is also made. Finally, a 0.1 molar 200 milliliter solution of silver nitrate is made. The potassium hydroxide is poured into the bulb bottom flask, followed by the 200 milliliter solution of 0.1 molar silver nitrate. The solution is then stirred and inserted into the fume hood. 8 milliliters of 30% ammonia is added to the solution. The solution is stirred again, and the reducing agent, glucose, is added to the solution. Solution is stirred, as you can see, silver starts forming. After the reactions are occurred, the flask is okay to be removed from the fume hood.
For silver nanoparticles, we will need 0.001 of silver nitrate, 1 gram of trisodium citrate.
We also need some distilled water, we need a thermometer, a hot plate,
We need beakers and a stirring magnetic.
Let's get right into it.
To start the procedure, you will need to prepare 0.001 moles of silver nitrate, and then you will need to obtain 50 milliliters of silver nitrate and pour it into a beaker.
After obtaining your solution, we place it on the hot plate and we have to make sure that it is stirring while heating.
While While the silver nitride solution is heating, we can mix the trisodium citrate with 100 milliliters of water. Use 5 milliliters of trisodium citrate solution and pour it into the silver nitrate solution.
Successful procedure will result in yellow solution.
Silver nanoparticles can be characterized by different analytical techniques such as TEM, SEM, and UV spectrum. This is the UV spec of the silver nanoparticles we just synthesized.
As you can see by these demonstrations that we've done today, regular silver particles vary in their properties from silver nanoparticles. Silver nanoparticles have different applications because of their different properties. For example, silver nanoparticles have been used as an antimicrobial agent. They can be used and added to socks to help prevent the bacteria that cause feet to smell. They can also be used for environmental remediation, such as water purification.
Thanks for watching!